So in this video, we're talking about parallelograms. Parallelograms are exactly what they sound like in the name. They have parallel sides. It's a quadrilateral, so 4 sides, where these opposite sides are parallel. So by definition, that's all a parallelogram is just a quadrilateral with parallel sides. A lot of cool properties come about though because of this. And the reason we have this in this unit is because you could actually split a parallelogram into 2 congruent triangles, and I can prove they're congruent using one of the properties we talked about last section. If these are parallel lines, then this is a transversal, and so I know these are congruent angles because they're alternate interior. Same thing, if these are parallel lines, then this is a transversal for them, and so these are also congruent because they're alternate interior angles. And so at this point, I know these triangles are congruent. Do you know which property it is? It's angle, side, angle. Obviously this side is the same for both triangles. So angle, side, angle, angle, side, angle. That's how I prove these are congruent. Since those are congruent triangles, that tells me a lot. That tells me that this is congruent to this is congruent to this, and also the angles are congruent. These 2 are the same, and these 2 are the same. And so all of that can be summarized here. In a parallelogram, the opposite sides are congruent, the opposite angles are congruent. That will always happen because basically it's 2 congruent triangles. In addition, consecutive angles, which are angles that are like right next to each other, always add up to 180. They are supplementary. So for example, A and D will add up to 180, D and C add up to 180, C and B add up to 180, B and A add up to 180. And the last thing we'll talk about is the diagonals. And diagonals are exactly what they sound like. It's just going diagonal through the parallelogram. The diagonals bisect each other, meaning they cut each other in half. Like these are congruent pieces and these are congruent pieces. Again, that's because they're basically congruent triangles. So we can use all of this to answer some problems. So here's a few examples. We've got a parallelogram right here. Assume this stuff's parallel, it says. So segment DE is congruent to what? DE is part of this diagonal. It's congruent to the other half of the diagonal, BE. It says if BD is 12, so if this full diagonal is 12 and AE is 7, what is EC? So the BD part was unnecessary information. You don't need that. This diagonal length does not depend on this diagonal length. But if AE is 7, then EC is also 7. Finally, I'm going to clear all this mess. If ABC, so ABC is 75 degrees, find BCD. So BCD is right here, and then CDA as well. That one's a little easier. Remember, opposite angles are congruent in a parallelogram. So if that's 75, this is 75. And then remember, consecutive angles always add up to 180. They're supplementary. So these 2 and these 2 should both add up to 180. So if you do 180 minus 75, that leaves 105 degrees for angle C there. On this one, I want to find the measure of angle EHG right here. I want to find this angle. Assume it's a parallelogram, and so since it's a parallelogram, again, I know opposite angles are congruent. So I know 9x plus 3 equals 8x plus 14. And I could just solve for x, so subtract 8x from both sides. So 1x plus 3 equals 14, subtract 3, so x is 11. That's not the answer though, it asked me to find the measure of this angle here. So what I can do is just take x, which is 11, and put it in. So 9 times 11 plus 3, which is 99 plus 3, which is 102 degrees. Note that if I plugged in 11 here, I should get the same thing because those should be congruent. Just a couple more examples. Find the measure of angle R. Well, it's just the same. If that's 135, this is 135. Find x. On this one, they don't equal each other. They're consecutive. They're right next to each other. So if that's 80, this is 80. But these two add up to 180. So remember, if they're next to each other, they're supplementary. So you could think about this a couple ways. Just do 180 minus 80 leaves you 100, which is what this would equal. And then you could solve for x that way. Or just add up these both. So do 80 plus 11x minus 10, just add them up, and they should equal 180. So you could solve it that way as well. 80 minus 10 is 70. Then subtract 70 from both sides. So 11x equals 110, divide by 11, and we get x equals 10. Make sure that makes sense. If I do 11 times 10, that would be 110, but minus 10 would be 100, which makes sense because 100 plus 80 would be 180. Remember that any quadrilateral should be adding up to 360, which makes sense because if you have 180 here and 180 here, the total would be 360. There are a few special parallelograms that I'm sure you've probably heard of. All of these are parallelograms. So these are like within the realm of parallelograms. You've got rectangles. Rectangles, the prefix rect, I think is German maybe, for right and angle. It literally means right angles. So it's got all 90-degree angles, all congruent angles. Again, a rectangle is a parallelogram because its sides are parallel. We've also got a rhombus. A rhombus is, rather than the angles being congruent, its sides are congruent. So the angles might not necessarily be the same, like here and here, but all the sides are congruent. I got a bad joke for you. Hold on. Why was the mathematician late for work? Because he took the rhombus. Okay. If you combine both of these, that forms a square. So a square is a rhombus, and it is a rectangle, and it is a parallelogram. That's why we say a square is a rectangle, but a rectangle is not a square kind of thing. In a square, it's a rectangle because it's got all congruent or 90-degree angles, and it's a rhombus because all its sides are congruent. And it's a parallelogram because opposite sides are parallel. So, just to be clear, a rhombus and a rectangle are not necessarily, like a rhombus isn't a rectangle unless it's a square. I just wanted to point out a couple other common quadrilaterals that are not parallelograms. One of those is a trapezoid. A trapezoid is one pair of parallel sides rather than two. There's actually a bit of debate in the math world of, is a parallelogram considered a trapezoid? A parallelogram has at least one pair of parallel sides. In fact, it has two. So the debate is kind of like, does it have to be only one pair of parallel sides, or is it just at least one pair of parallel sides? And I guess you get to decide. Typically the trapezoids we see are only one pair of parallel sides, but Again, it's a bit of a debate in the math world. A couple other random ones. This one is actually called a kite. A kite literally looks like a kite. It's got two pairs of congruent sides that are right next to each other. They're adjacent. So two consecutive pairs of congruent sides. Again, this is not a parallelogram because like these two are not parallel, these two are not parallel. And this is just a random, I guess technically this is a kite actually, because those are the same and these are the same. This is called concave because it caves in on itself.